Hi, and welcome back to Faster Futures from Silicon Valley. I'm Ron Morris, Director of Omnis Education San Francisco. In our first seminar, I welcomed you from InSeek U San Francisco. But as many of you now have heard, last week we adopted our new name of Omnis Education. Nothing else has changed, and we are excited as ever to be designing and delivering programs for our 12 schools and 30,000 students. And this program is at the center of it. We are focusing on helping you build your future faster. I also wanted to thank you for the positive feedback on our first session. If you missed it, you can view it here on our YouTube playlist. It's an important one because our innovation experts, Mark Bunger and JC Velton, laid out some core concepts for this series. Also, please note that the next Faster Futures will be on November 18th at the same time and on the same platform. So please do subscribe to this YouTube playlist. And today it's quite exciting because we've got both students and alumni, and feel free to invite anyone else who you think would benefit from this session. So today we have a fantastic session on the future of robotics. Mark and JC will begin with a high-level view of the industry before leading a discussion with Todd Meany from Facebook Robotics. And we want to cover the issues that are important to you. So please do ask questions in the chat, and we'll incorporate as many of them as possible into the conversation. Then, once we finish this session after an hour, we're going to kick off our first ever backstage bonus. You can join us then using the Zoom link that you can find here in our YouTube chat. And we will come together in a more informal discussion, covering more insights, stories, and questions that we were not able to cover in the first hour. So with that, I'm going to hand it over to Mark Bunger, and here we go.
Okay, morning everybody, and very morning, afternoon, or evening, depending on where you are in the world. I'm personally here in Barcelona, so same time frame as a lot of the rest of you. Juan Carlos and Todd are in California, so early morning for them. And yeah, as Ron said, we're going to start out with just a brief overview of the past, present, and future of robotics. And that will hopefully get everybody up on the same page. So we'll have a really interesting conversation with something you probably didn't think that Facebook had, and that's a real live robotics engineer. So to get that started with the caveat that this is really meant to, as I said, get everybody on the same page. If you're an engineer, you probably know 90% of the things I'm going to be showing you. If you're on the business side, you might not be as familiar with what I'm presenting. But again, this is really just to kind of get us primed for a great conversation about the future. So I am going to share my screen. Great, and everybody can see this okay? Thumbs up, great. Okay, so this is the second in our series, Faster Futures from Silicon Valley. And again, today we're talking about the future of robotics. So for about the next 20 minutes or so, I'll be presenting just some overview of the past, present, near future of robotics, what's going on with things like autonomous cars, drones, industrial and household robotics, human-robot interactions, and then some things about ethics, economics, and ecologics, where this is all going. And hopefully that will be a good lead in to our conversation with Todd. So Juan Carlos and I have prepared a number of questions, and also Ron too, of course. But what we're also, we have an open channel for you to ask questions. And then again, at the end of the hour, we're going to go into an open Zoom, where it's pretty much, free for all. It won't be live streamed. It'll be just for us, where we can have a more open conversation. All right. So as I said, we're going to talk a little bit about the past, present, and near future. And a real just high level overview, if you think about robotics. Way back, 500 years ago, Leonardo da Vinci was thinking about mechanical people and ways that you could make structures that looked and acted a lot like living creatures, using bones and muscles and sort of the equivalents built with rope and rods and things like that. But the real dawn of what we think of as robotics was really in the early 1900s. And so you had robots like, Electro by Westinghouse, a big electronics and engineering company in the 1930s. The word robot was actually from the word, the Slavic word, the Czech word for working, roboto, and you still hear that in, like in Russian, robotayo and things like that. So it's basically meant to be a worker. And this idea of an anthropomorphic machine has really stuck with us when we think about robots. But in reality, since then, what people found out was that it was really hard to make machines do a lot of the things that we take for granted. Just like walking upright, seeing, talking, these were all problems that until very recently were very far from solved. So for most of the 1900s, robots really looked more like just complex machines. So you had basically things that looked like, an arm attached to the floor with hands. In a lot of lab automation, you see things that really look like, they're closer to something like a copier or a printer machine that just do repetitive tasks, but we still call them robots. And so it's really only now that we're kind of getting back into this idea that biomorphic robots, things that look like humans or dogs or animals, can start to have, we can start to basically make machines that can navigate the spaces that people and animals are used to getting through. So a few years ago, I was in Palo Alto near Stanford University, and there was a store there. It's called Beam, and it was by a company called Suitable Technologies. And as I was walking past, I saw a robot that looked a lot like this. It has an extremely realistic face, but not a lot else is very, again, what we think of as robot-like. Except for moving around, it can't really do any work. As I found out, the face is actually another human. So there's a pilot working with a robot. She was sitting in Berkeley at Berkeley University, and she was a student there, but this was her, her job when she wasn't in class. And before I, walked up and approached this robot and learned all that, I saw a lot of people interacting with the robot. They would stop and ask it questions. I would see her talking with them, and some people were very engaged. Some people were kind of terrified. And so after seeing, this robot basically working in a retail store, the store was a robot store and it was manned only by robots. I guess you wouldn't say manned by robots. It was roboted only by robots. Anyway, no people were in the store. And so I went and said, hey, this has been fascinating watching, all the passersby coming here for the last 10 or 15 minutes. What is, explain what's going on. And this is where, again, she explained that she was a student and she was actually sitting, many kilometers away, guiding this thing. But what I was fascinated by was this human interaction that she had shown. And she said, this job is really hard. It's not that driving the robot is hard, but it's more like if you were living in an embodied internet chat room with all the crazy comments and things that people say to you and all the things, what people that do when they think that, they're not interacting with a person. And so, a lot of it was very offensive. Some of it was kind of strange. She said that when people would stand too close to her or touch the robot, she felt like it was, invading her personal space. And a lot of people, no matter how hard she tried, weren't convinced that she was not actually a robot. They weren't convinced that there was a person there, no matter what. So this is really kind of where we are today with robots. We don't know what's real. We don't know what's fake. And so as a user, as a designer, as an engineer, you have a lot of questions that, even though we've been thinking about robots for more than 100 years, we're really just now coming to starting to come to terms with and starting to learn about. And so, you might say this isn't even really a robot, right? Does it pick things up? It moves around, somebody's guiding it. That's maybe not what I had in mind. So let me tell you a little bit about what's happened just in the last few years in terms of capabilities. You might have seen the DARPA Robotics Challenge. So like I said, just a few years ago, we got to the point where we could actually start thinking about making bipedal robots that acted and moved like people in spaces that people move in and things like that. And I'm going to flip over to YouTube to show you this video, but you've got the link below and you can click on this later. We're going to make the materials available, but I just want to show you what things look like just back a little more than 5 years ago, 5-6 years ago. Okay, so you might have guessed that the challenge there was to get out of a car, walk over and open a door and turn a knob, and none of them succeeded. But you've probably seen these Boston Dynamics robots that today are doing amazing things that are even scary at their agility. You know, if a human was able to cross a space as fast as they can, you know, it'd be pretty impressive. And these are robots now. Just recently, a couple of days ago, Disney announced a bunch of its sort of upgraded robotics program. And so you might have seen this as well. So if you remember Groot from the Avengers movies, Disney at their parks have a lot of animatronic, as they call them, sort of, you know, mechanical versions of their characters from their movies and shows. And so I'll show you kind of the latest and greatest from that end of the spectrum now with another video. So this is starting in about 2018, and you're seeing how this is evolving. So yeah, that's what, you know, 5 or 6 years of progress looks like. This is definitely, you know, boom times in robotics, and so it's a great time. So it's a great time for you if you're thinking about careers to take that into consideration. You know, entering the field, you want to work with robotics, avoiding fields that could be replaced by robotics. Yeah, just this is what we tell you today is only setting up the stage for what's going to be happening in the 5 years ahead. And a few years ago, I was in Los Angeles and talked with a Disney Imagineer who was working on some of these concepts, but more from the human interaction side. So to kind of put the the bookend, the mirror image of the conversation that I had with the woman driving the robot in Palo Alto, this engineer told me that what they were really looking for is a seamless experience for example, when a kid comes to a Disney park and Buzz Lightyear is there, they want that Buzz Lightyear or that Cinderella or that whoever to have some understanding of this child that they're interacting with. If the child is, read a story or they have the doll at home, they want the doll at the park to have some connection with the child's own specific toy, so they can continue a conversation or really have some continuity, so that the role that Buzz Lightyear or whoever plays in that child's life continues at the park. So maybe that's creepy, maybe that's a great idea, maybe that's just I don't know, we'll see. Maybe it's impossible, but whether or not it is, these are the types of questions, back to the ethics and what we're facing right now, that are going to be happening more and more. So if that's the current sort of visual status from a business perspective, why is this happening now? What's different about the last 100 years when we had these movies and these pictures and this sort of mythology around robots that's making things happen? Well, the first one is very much on the engineering side. We've seen lightweight materials, motors, smaller computers being able to do computation, even battery chemistries, new types of batteries that make robots lighter weight. If they're lighter weight, they have less, mass to move around, so the motors can be smaller, and then that leads to lower cost. They're also much more agile, and they're much more autonomous than they've been in the past. So each of these I want to spend just a couple minutes explaining. There's a concept I love in engineering called recursive decontenting. And basically, if you think of that as, to explain what that means, content, think of that as like the mass of a vehicle or of a plane, or in this case of a robot. Because if you use lighter weight materials, you can use smaller motors. Now those motors weigh less and they use less power. So you can have smaller batteries, which means you can have even smaller motors. And that means that the smaller motors can, you want to have even lighter weight materials. So you get in this virtuous cycle where as one thing gets smaller, everything else can get smaller in turn. And we're kind of at a point where this, the robots that you saw 5 years ago that were falling over, just trying to turn a doorknob, they were so heavy that if they fell on you, they'd probably, if they didn't kill you, they'd send you to the hospital for sure. And they were remarkable in that these were robots you could actually be around. Most industrial robots have a cage, either that the humans are in when they're near the robot, or that the robot is in where it's doing its work. Because if one of those industrial robots on an assembly line, something goes wrong, they will take off a hand, a head, they'll solder your arm, they'll do all kinds of bad things. And so the fact that we can actually be around these robots now is due to this this recursive decontenting, this virtuous cycle of having lower cost, lighter weight, and less danger to humans and to the rooms and the spaces that people are working in. So that brings me to the second thing, agility. So if you're really massive and heavy, you need to move slowly, and you can't move in, you don't have a lot of degrees of freedom to move. And so now with these lightweight robots, they can move more quickly, but they can also move through more natural, complex spaces, the types of places that we find ourselves. So again, you've probably seen some of these Boston Robotics machines jumping around. If you haven't, definitely Google it. But very recently, Hyundai, the car company, bought Boston Robotics. And you might wonder, like, why is that? Well, Hyundai has been working for many years on a project to make cars that walk with legs, that basically, can move from wheels to climbing up things. And as you see this picture over here with the New York City taxi, this is just a concept picture. Obviously, it's not real yet, but they're working on things that could, take the place of certain types of construction equipment or rescue equipment, or, in other ways, address spaces that cars just can't go today. So we don't know where all these robots are going to be going, but I think, again, our imaginations of the roles that robots have played are just about to get a huge boost and a huge jolt. The last thing is autonomy. So, as I mentioned, the robot that I ran into in Palo Alto had no autonomy. It really had no smarts. It was, I think it was able to find its way back to its charging station alone, but everything else humans did. And now, just a few years later, it's exactly the opposite situation. Vehicles are often able to guide themselves better than humans through complex situations like traffic and like urban environments like sidewalks and things like that. And so the fact that they don't need human direction, or in some cases, they don't need human direction except for a very complex task, means that we can use them for a lot of things that humans have previously had to do. And so what I mean by a human, like a hybrid situation where a human takes over for a complex task is in some cases you have freight trucks that will drive the long straight stretches without human intervention. But then when it comes time to come into a parking lot, come up to a loading dock and then finally, pull up and open up and deliver their cargo, they'll hand that off to a human. And so there are a number of these sidewalk robot vehicles that work the same way. They work autonomously, except in situations where they're not sure what to do, they run into a hazard, they run into some kind of trouble, then a human will step in. And I know of one company that's developing these where the drivers are based in Mexico City, the vehicles are being tested in California. And I think this kind of telepresence that I was mentioning earlier sounded before kind of like that was sort of a band-aid on a problem, or it wasn't really solving the problem. In fact, this is how a lot of these situations will actually deploy. So the same way we didn't go from full petrol vehicles to full electric vehicles, we've mostly been driving hybrids for the last 15 or so years. There will be these hybrid situations probably for, on the order of a decade or so. But that means that we'll get robots faster than we otherwise would have expected. And that's really important because a lot of the things that these types of robots are doing are taking away, in some cases, jobs that people get paid to do. I read an estimate that something like 25% of men's jobs have to do with driving something. I don't know if it's true, but it's a very large number. But then there are also tasks that are unpaid work. And so a lot of when we talk about women's unpaid work, it's driving to the grocery store or taking kids to school or doing other types of things that are really a job. They're not for fun. And that's not compensated either. So in both of these cases, we've got opportunities and potential problems from the rollout, no pun intended, of autonomous robots. So where are things today? And again, why is that different now? Those three factors, the lightweight, low power, low cost, is leading to agility, that's leading to autonomy. And the three of those together will be leading to ubiquity. So this is again, a concept picture from Continental, the German automotive supplier, from a few years ago. And they had this idea that basically we would have something that we've started calling nested logistics. And by that, we mean that you have vehicles riding on vehicles riding on vehicles. Rather than, for example, a drone or one of these little delivery dog robots go all the way from the store or the warehouse to your house, you could see them riding in like the equivalent of like buses or vans, or even taking public transportation. You might see this on the metro in a few years, where they go in and they get to their destination the same way we do. They take large, fast, shared communication modes, like again trains and buses and things like that, until they get to the last mile or even the last meter, taking things right up your doorstep. And when that happens, I think the way I've started thinking about what robots are going to look like in 2025 or 2030 is a lot like what the electric scooters and electric bikes look like in a lot of cities, where some cities manage them well, and in some cities they clutter up the sidewalks. They're all over the place. They're kind of a mess, right? So even though this seems really super space agey and far off in the future now, these things have a tendency to flip really quickly into being like everyday normal part of your life. And kind of like, your smartphone is 10 years old and you can probably not imagine life without it. So 10 years from now, we could very easily be in a world where we can't imagine what it would be like to not have these robots kind of scurrying around everywhere. And why would Continental care about this? Well, if robots are doing a lot of these delivery tasks, if autonomous vehicles, which is another kind of robot, are taking us places and then taking other people places when we're not in them, we need a lot fewer vehicles. We could basically get by. Most cars and vehicles that we use to get around today are utilized about 2 to 3% of the time. If you own a car, it's probably running about 2 to 3% of the time, and that's true for all of them, which is a terrible use of such a large, complex, and expensive piece of capital utilization rate like that. So in theory, we could get by with roughly 1/20th as many vehicles and get the same amount of transportation out of it. So if you're a car manufacturer and all of a sudden the market for vehicles is going to go down by 95%, you need to know about that. So that's why you see every car maker has a robotics program, an autonomous vehicle program. So we'll see how fast that happens. We'll see what safety issues they solve and so on, but it's a really exciting time ahead. So with that said, we're going to jump over into our conversation with our guest. Thank you for listening, and hope you can prepare some questions for him and for us. I'm going to stop sharing and we'll jump into the conversation.
Mark?
Yeah.
There's 1 or 2 questions for you, since we have 2 minutes in the chat. Alexander Viviano says, could we say that robots of nowadays are aligned with Asimov's 3 laws of robotics?
Asimov's 3 laws of robotics, sure. So for those of you who don't know, Isaac Asimov was a science fiction writer in the mostly in the mid 1900s, so like 1950s, 1960s. And in his stories, he formulated something he called the 3 laws of robotics. And they were, I think, a robot cannot, through inaction, allow harm to come to itself, to another human being, and there was some other. At any rate, they're sort of the beginning of ethical laws of robotics. And in fact, there was a 0th law of robotics that a robot cannot, through action or inaction, allow harm to come to humanity. So through whatever science fiction magic Isaac Asimov had in mind there with the positronic brains, these ethical laws of robotics were actually really insightful, and people think about them very much as a template for how we might apply ethics to robots today. So most of certainly none of the situations, in fact, that were in those science fiction books are things that robots make decisions about today. They're barely getting their shoes tied, but I do think in the next few years we'll see situations where robots, especially with autonomy, will need to be held accountable for their actions, and we'll need to have some guidelines for how to get through some of these difficult decisions. An example people talk about a lot is like if a Tesla autonomous vehicle is driving along, in autonomous mode, and a child dashes out into the road, and the alternative is to either hit the child and kill the child, or swerve onto the sidewalk and crash into a tree and kill the driver of the car. What's the right course of action to take? Personally, I think a lot of these things are mostly for philosophy departments to think about. I don't know how often those types of questions will actually come up, but in a related area, what we're seeing is actually happening more on the legal side, is people are taking corporate law and applying it to robots. And so the idea here is that an autonomous robot is making decisions without human intervention, and it needs to be accountable for the wrong decisions, but it could also actually profit or benefit from the right decisions. And again, this sounds really ridiculous, but this is exactly what we do with corporations today. If you're a corporation, you can have liabilities that the people that work in the corporation or even that own the corporation don't have. So what lawyers are doing, they're taking this corporate law and applying it to discrimination decisions, to investment decisions, and things like that. So look for places like Estonia to put those types of rules in place first. But good. Thanks. Hope that answered your question.
Okay, on to Todd. Can you introduce him, Mark, please?
Yes. Okay. So Todd Meany is a friend of mine. We actually met through robotics several years ago, and another friend and former colleague who is now a venture investor, and she makes a lot of investments into robotics. But I was also struck by, okay, robotics at Facebook. What does that actually mean? And Todd, before being at Facebook, was at iRobot, and has built a lot of the again, some of those early stage robots that you saw in the DARPA competition. That was probably when you were in the thick of it. So for today's conversation, and in fact, all of these conversations, I should say, we're going to talk with Todd about his experience, his career choices, his interests, and things like that. We're not going to talk about the company, Facebook. We're not going to talk about tell us the secrets and what does Mark Zuckerberg really eat for breakfast and those types of things. Those you can get all that type of stuff in the news. We're here to talk about you are all students looking at career decisions. You've invested in this program and you're investing time in these talks, and we want to basically help you be as prepared as possible for the future. And so we're really grateful for Todd to be here today with us. Our first guest also, by the way, in the series. So any glitches are our fault, not his. But yeah, Todd, thanks for taking the time to be with us.
Yeah, thanks for having me. I'm excited to be here today.
Yeah. Did I miss anything on your bio, by the way, that you'd like to add?
No, I think it's pretty good. I mean, I think I've had a really interesting career, which I've been very thankful for. And, a lot of it's just been gravitating. If it's not robotics, it's been sensors and actuators and toys and just being creative. So yeah, it's been a lot of fun, and it's brought me here today. So I can't complain.
Excellent. Great.
So the format, just to let you guys know, is we are going to ask Todd a few questions, and he's going to answer. And we have designed the questions so that there's learning from it, and there's a sequence. We are going to ask him 6 questions, and we are going to ask every speaker the same 6 first questions, and then we're going to ask some specific questions for him and his specific job. So we begin.
Yep, that sounds great, JC. Thank you. And we've got a couple other questions we haven't gotten to yet. Again, just as a reminder, keep your questions coming in. And if we don't get to all of them in the hour, that's why we've created Backstage Bonus. And it'll be an opportunity for more informal conversation covering the other questions. And again, I wanted to say thank you, Todd, as well. So thanks for joining us.
No worries, thanks.
Perfect. Yeah. So the first question is, Todd, can you tell us what a day in your job looks like?
Sure. Yeah. I think these days, I think it evolves over your career, of course, but these days I find myself doing, having had a reasonably long career is, mentoring people. That's one of my favorite things to do is, when you join a company like Facebook, Apple, Google, usually you're assigned like a mentor for a year to help you come up to speed in a company. And so I, typically once every year, I'll be assigned someone, and I get to basically help them, usually right out of school, help them come up to speed. What is it like to work at Facebook? What is it like to work at Apple? How do you navigate such a big company, such a public company? And then usually there's like the company aspect, of the culture aspect. There's also the technical aspect. So I'm kind of helping them set the bar of here's where, here's what we expect out of you during the first year. Here's what we expect out of you during year 2. And also giving them the chance to not turn the fire hose and say, here, you drink all this. It's no, we have onboarding plans that get people to feel comfortable. The last thing you want to do is scare someone off, 2 weeks into their job. So it's how do you ease them into a really high paced, company. The other thing I do is a lot of interviewing. At times, basically helping. A lot of interviewing is cross-functional, so I help other teams hire people. So it might be a technical interview for one group. It might be sort of not a cultural, but like a behavioral interview to see does this person can get along with people at Facebook? I think I'll be able to be productive there. So that can be a lot of fun. And then I guess writing and documenting and planning are another big thing I do is I'm less hands-on in the lab, doing experiments or building stuff every day now. I'm more concerned. A little bit of that has to do, of course, because of the pandemic. We can't travel. We can't be where we want to be. But a lot of it's just thinking about being strategic. What are we going to build? When are we going to build it? What are the building blocks we need to get this thing done? And then that was probably a high-level summary of what I do every day. Although I do get the chance to go into a data center or play in the lab, and I do really enjoy those days as well. It's nice to be hands-on and playing with hardware again.
Yeah, great. So I get to ask the second question, and it's pretty broad, but how would you define innovation?
Yeah, that's always a great question. It's like, how do you define a robot sometimes? I think innovation for me is the introduction of something, sort of new and clever. And it's, something that may not have existed before. And oftentimes I think innovation is often sometimes, misunderstood by a lot of like the late majority, only maybe the early adopters and early majority kind of understand what it is, and then it gets propagated. I think innovation is, it doesn't always have to be a device too. I think when we think about innovation, we think about, oh, look at all the cool things that Apple's done with their iPhone and this and that. I think you can be innovative in a bunch of areas. Like, healthcare, how do we improve like some healthcare process? Is there financial, like how do you become more innovative in the financial realm, right? Like, we went from like, you have to go to a teller to do a transaction. Now I can do every deposit checks on my phone. I can do my banking, anywhere I am at any time, which, frees me up from, all these, obligations of going somewhere to physically do something. There's innovation in farming. There's innovation in medicine. I think it's a really broad field. It gets a high level definition of what I think innovation is.
So to take it to more of innovation within a person, what do you think are traits of innovators?
I think, the first thing is be observant and ask why. There's like, it's easy to get on like on a bus every day and go somewhere, train and just say I'm heads down reading my, scrolling through my Facebook feed or something. And then, but to look around and wonder why things happen and why things are the way they are, it's really key, because that gives you the insight into like an opportunity to make something, potentially improve something, whether it be a product or a process or an experience. There's things I always look around and wonder why people have made the decisions they make, right? So, growing up in the US, all doors of buildings open outward, because if there's a fire, you can push, and the inclination is to let people out into the open and get away from the danger. I mean, Germany is one of my favorite places on earth. But in Germany, I find myself in a restaurant and the doors open in, and I'm like, what was the decision process that that made why is that the way it is, right? And being the Germans are amazing, like sort of engineers in general. It's like there's a good reason for that. I still don't know what it is. If someone knows, like please share with me. But I think it's making observations like that. Like, what is the difference? Like, even in Germany, the way the windows open, right? They open in a very clever way that makes them easy to clean, easy to get airflow, but still somehow keeps the bugs out, where the US is taking a completely different approach. So I like to make these observations and ask the question, like, why is one better than the other? Is there an absolute better one, or is it just a preference based on your geography, for example? So another, like, if you want to see like a good example of being observant too, like Seth Godin has, he's on, you can see this video on YouTube. He's got this show called It's Broken, and he's super observant about like, why are things the way they are, and like, how do they get there and what you can do about them. And he has a really good list of the 7 things that basically, if you look through this, watch this video, you'll see, wow, there's all these opportunities for innovation based on just observation and empowering people to make those changes. I think it's important also to question why something is, right? As I mentioned before, like, you can make an observation, but then like ask why that is, and can you make it better? And should you make it better? And what would the impact of making a change be? And I think that leads me to like sort of the third point is, you have to be, if you want to be an innovator, you have to be bold and think about how a thing or process can be improved. No one's going to sit around and do it for you or take your idea and run with it. Usually, you have to do a lot of the heavy lifting yourself. It's going to take a long time, some cases. But also note that there's a huge difference between like being an innovator and then being someone who tells everybody else what's wrong. So, at the end of the day, the outcome might be the same if you get your way, but you really want to like build people up around you to say, hey, this is really interesting, we should do this, rather than pointing, saying, hey, everything here is wrong, this is the best way to do it. Because everybody has different opinions. And if you really want to make a change, like it's a cultural change. It's not just a physical change to an object or process.
Yeah, I love that about being observant and curious and all those things. Well, so then scaling back up, if you think about your organization, can you tell us a little bit about, again, with the obvious, there's a lot of confidentiality and things like that, but what are some ways that your organization innovates? How does that happen? Do you use like, Kanban, Agile, methodologies, or their mottos and sayings, how does that work?
Yeah, of course. I'll say this. I mean, everything I'll say here is, pretty publicly well known about Facebook. I think innovation has to be fostered, right? So we from the beginning of Facebook until this day, we embrace like what's called a hack culture. It's an opportunity to step outside of your normal day-to-day grind, or not, that's the grind, but your day-to-day, work, and say, like, I got this really good idea. I think it could be something, right? If you were told no all the time, then you would never innovate. You would just, maybe you wouldn't like the company, maybe you just do your job. But when you're given the opportunity to innovate and you're encouraged to innovate and you're given the resources to innovate, it becomes part of your culture, and then people around you support your ideas. So, that's, very much how a lot of the stuff that I've worked on come about. It's, someone said, hey, I got this idea, let's explore it. And I think that the sort of along with that is like not only the hack culture, but what success looks like. I think that a lot of people say, well, unless I'm succeeding at everything I do and everything works, then that's innovation. And it's not really true. It's important to accept failure and accept it quickly, because not everything is going to be a genius idea that's going to work out. And maybe it won't work out today. Maybe it will work out in 20 years. We don't know. But you definitely don't want to spend a lot of time on stuff that's not going to work. So we are given, like almost like a 50% criteria. Like, yeah, it's, it might work, it might not. So if it works, great. If not, let's bookshelf and revisit it later. And there's no shame in that. You didn't fail. You tried something and you learned something, and now we're in a better place than we were before, even though that product might not go anywhere, or that thing might not go anywhere. So let's see.
Todd, maybe could you just, to make it clear, because a lot of our viewers are coming from a different culture and different language, just how would you define hack culture? Because you kind of put that at the center of your process.
Hack culture, it's a culture of where, like I said, innovation is sort of, fostered. So I think one thing I want to mention too is, like, at Facebook, titles aren't really big. I know you go to a lot of companies and you're a senior principal this or you're VP of that. We really don't share titles, or we can make up our own titles. So it doesn't really, so you don't get to a position where I feel like I'm always have to listen to the most senior person, that the most junior person should be ignored. We really embrace that we're all there together to make something awesome happen. And that can come from anywhere. And it should be supported by everyone. So that's, part of that culture. And it's because of that, everyone has a voice. And so, when it comes to this hack culture, anyone can have an idea, and you have a forum to present that idea to a broad audience, and they could support and feedback on your idea. And so at the very least, you're there learning and observing. And at the very most, you're actually, creating some whole new business unit or product for the company.
Yeah, I think that's interesting cultural difference, because for some people around the world, when they hear the word hack, they're thinking of something negative instantly. And obviously that's not the approach in Silicon Valley.
No, I mean, a lot of companies have hack forums and hackathons, and it's also, it's more than a culture. It's also like, like a meeting. It's a scheduled time to do some things, right? So it is like all hands on for some amount of time. So your hack might be a day. Hack might be 48 hours, where you're going to spend 48 hours just you and a small team, like, what can we get done? And they might compete against each other. Who can have the coolest idea to solve this today? So it's also like, it's bringing people together. It's more than just a concept. It's something we put into action all the time.
So talking about hacks, what do you think is the relationship between technology and innovation? Because, in Silicon Valley, we might be biased by everything that is innovative needs to involve new technology. What do you think should be the right balance between technology and innovation?
I think the difference between technology and innovation is that technology is the most sort of physical and well-known, like, physical thing of innovation, right? You see like a phone or something, people think that's really an innovation. You see flying cars, that's innovation. Like I said before, I think the innovation come in a number of ways. It can come in things like better building materials that are more ecologically friendly. It can come in, like more efficient transportation or something where, it's overall net good for humanity, but it's not necessarily the latest gadget. So I think it's important to think of innovation as lying outside of technology as well as being the latest, sort of gadget. And I think that, the difference between technology and innovation is, technology just really buys you time. It keeps you ahead of your competitors. You're inventing like the next generation of something. I think that innovation is really what gives you that leap, right? It's sort of like the first iPhone where, we're getting, better and better Nokia Motorola phones, and they have like better versions of Snake on the phone. It's just like you're doing incremental changes. And all of a sudden, like Steve Jobs comes along, gives you like the first iPhone. You're like, wow, like game changer. That's real innovation to me, and I'm trying to think of examples outside of the technology industry where this has happened. But, I think Tesla would be another good one, right? Where even if Tesla's not the most successful car company ever, they've set the bar, right? Everybody's incrementally changed. I'm getting a little better fuel economy. I'm kind of doing these hybrid models. And all of a sudden Tesla comes along and says, no, we're going to fully battery operated, fully autonomous in some timeline, and that's what they've done. And they've done the same thing with like space travel, right? You've seen people like, say like NASA's is a massive, great organization. It'll kind of launches shuttles once in a while. And then SpaceX comes along and says, yeah, we're going to do this once a week and we're going to put people in space, So I think there's not incremental changes. There's a real big, like sort of steps there.
So do you think J.K. Rowling was an innovator when she wrote the first Harry Potter?
I have to think about that one. That's a great question. I mean, it was certainly popular, but is there innovation there? I'm inclined to say I love the whole Harry Potter series and books. I don't know if there's like a lot of innovation there. I mean, lots of great authors create worlds. They tell these really long stories, like Tolkien obviously has done that. But was there anything new to what she has done? If there's anything new that's what she's done, it's her marketing. It's basically she's able to get a big audience, with a really quality product and create a great movie franchise, and then all this amazing sort of things that come out of this, like people actually play Quidditch in parks, right? So I think like if there's innovation, it's her marketing and distribution. Maybe that's not what she intended, but that's what I think would happen.
Yeah. Todd, we were talking a little while ago about, like you mentioned, failure. It's okay to fail. It's 50% of the time things work out. You're definitely in the safe zone. I wanted to mention. So you've got this sort of vlog or blog that you do about Todd's Tech Fails, and it's all these pictures of things that are just not doing their job. One of the best definitions I've found of innovation is things that don't quite work yet. And so can you talk a little bit about, the blog is obviously funny, it's funny failures, but there are also things that, they illustrate something interesting about new technologies, right? Can you talk a little bit about like what you write about, what you find funny, what the reaction is, and maybe if people want to start following you, any way to do that?
Yeah. I will. We can figure out how to share that. Right now, it's kind of a closed group just to my friends because there's a lot of.
I was not sure if you wanted to do that.
But I'm happy to share because I think it's I think
put the link
important.
In for that reason.
Yeah. And thanks for laughing at my pain. But it's I started this because I started it because I found that things fail, and it can't just be me, right? Like my AirPods fail all the time. And it's like, so what I started to do is like, I'm going to start throwing this out there with my friends who are in technology and say like, for me, it's like almost a diary of failure, right? It's just, am I making this up or things happen all the time? And a lot of people thought, like some people say, well, you're just complaining, but then more people come back and say, hey, I've got the same problem, which is really interesting because it makes me feel not alone that like my AirPods fail all the time. And you'll find that the same AirPod that people are like, oh my God, your right AirPod fails all the time. So in one way, it's like an honest data collection system to say, Apple, like your stuff really doesn't work in this case. And here's why it's failing. I thought of a failure yesterday that was unbelievably bad time. So I have a Audi car and it's remote control, super sensitive. And if you look at it the wrong way, the tailgate opens, so that the back door opens. At the same time, I was putting my camera, trying to get my stuff ready to go out to shoot some photos last night. And I hit the garage door open. The garage door starts to come up. My tailgate button just triggers, and now my tailgate wedged my garage door. They were fighting each other. Yeah, I wish I'd taken a picture instead of started swearing a lot at it. But but these are like things that I think would be useful feedback to companies to actually, to make a difference and innovate and really get a pulse on what their customers want. I think one, it's hard to do because there's so many people out there that have technology and that maybe only a small subset of them have problems, but those problems can be pretty big sometimes. And so I think that by just bringing people together and saying, hey, you're not alone in this. and is really key. And then also telling the companies like, hey, a lot more people are having this problem than you think, or maybe you think it's a simple problem, but it's not. Maybe you should investigate this. Yeah. So I'm happy to share the blog. It gets added to all the time. So please feel to follow it.
Great. Okay. Well, so I think we've got time for one or two audience questions, and then again, we're going to continue with more of that, but in the next Zoom meeting. I will start. So there's maybe I'll give you two, and you can answer them in the order that you like. One is a very practical question: how are the current chip and battery shortage affect the field of robotics? Second one is innovation is about culture. Love it. In your opinion, in what field robotics won't be able to replace human beings?
Let's talk about the chip and battery shortage first. I mean, it's affecting everything. There's like I have friends that own car dealerships, and they're just like they can't get inventory. There's some experiments. Look at ordering parts. The lead times have gone from would have been 6 weeks to now 6 months or a year before stuff comes in. So it's going to impact, every industry, right? It's kind of wondering how Apple's shipping iPhones at the volume or new watches at the volume they're shipping given the shortage. So I think in some ways, some people have got it figured out, but in other ways, it's just going to affect everything globally for a long time. So even like with the Amazon delays, you're seeing things that used to arrive in 2 hours here, used to arrive in 2 days, now we're taking that week. So in general, I think everything's going to go out, and I think the robotics industry is no exception. I expect you to see this from Roombas to Teslas to anything at this point. Mm-hmm. And so what was the other question? I think it's listed in the chat somewhere.
Yeah, it was, are there any jobs that robots won't be able to take?
That's a great question. I think for sure. I think that they're going to supplement a lot of things. Like you'd say, robotics will replace like surgeons. So you'll never, I don't think, replace a surgeon, but obviously with like Da Vinci and stuff, you're starting to, supplement humans because there's just at a precision level that, you can't get any other way. And also too, they allow for those, small micro movements in the sterile environment that your incisions and stuff now become, the doctor just doing them remotely. Obviously your incisions are smaller, they're more precise, they're in a sterile environment. So your recovery time, success rate goes up, recovery times goes down. So I think you'll see a lot of careers where they'll be supplemented. Like a driving, like the driving example you mentioned before, right? You're not going to replace a human behind the wheel for a very long time. I think a lot of it too, not because it's not capable, but because of the assessment of blame if something goes wrong. But they're going to supplement drivers, right? You're seeing all this already in the aerospace industry where planes can basically taxi, fly, land themselves. You still have that human. The pilots aren't going anywhere anytime soon. It's funny. I've been on this nostalgic sort of sci-fi kick recently where I read Blade Runner or Do Androids Dream of Electric Sheep, and then watched both movies again. And the book is really interesting because it talks about using robot animals to kind of provide empathy for humans. And so I start thinking about things differently. Like, well, if they're not going to replace humans, would they ever replace animals? Would you ever feel like in the book that your electric dog is as good as a real bio dog, right? Mm-hmm. And I don't know. That's a tough question. So I think they're just going to free humans up for humans to do more interesting things. And the idea of a robot is just to right now take on the dull, dirty, dangerous. So that's So that's not too sure.
Yeah, okay.
I think we got time to think about it.
Yeah, it won't be tomorrow, but okay, great. Well, we actually do have a few more minutes. So Ron or JC, do you have another question, or I can go back to some of the audience questions?
I'd like to follow up with a question from the audience, and the one question was, because we talked about, and I think it kind of connects with what Todd's talking about, empathy and how we feel about robots. And it seems as though a question from Severine is the future of robots only driven by human mimesis? And I think that's a kind of interesting thing. Like, why are we making robots look like humans, look like other live beings? And is that something that you think that is temporary, or is that durable?
I mean, there's a reason why we want to make robots like look like humans. I mean, humans live in a very unstructured environment, and you hear about people like Roomba proofing their house because they're making their house more friendly for the robot to do the thing they do, right? It'd be great if like we didn't have to do that. If the robot could come in and just use the vacuum I've already purchased and just navigate my space and do cleaning. So for that aspect, building a robot that looks like a human just means it can navigate the human space better. Another reason is that there's maybe a comfort level. Maybe this is like that subconscious empathy of something that you have. Like if you can't see a driver for a autonomous bus, for example, the bus just becomes this entity. But if you have this like some humanoid robot driving it that has some personality or something, maybe you feel a little more comfortable interacting, with that versus just like a screen. Would be one reason I think everything would look like more like a human. How that's going to evolve over time, I'm not exactly sure.
Actually, to illustrate this, there's a good question here from Anastasia. She says, how do you define a robot?
Yeah, robot to me is really okay. So I've struggled with this for many years. Like this is the biggest questions I've had in robotics, and I've talked to everything from students to friends and colleagues. And robot obviously it can be a physical thing. So it's this thing you see, like it's like a Roomba. It is like a Boston Dynamics something, right? So that's a physical thing. But is it really a robot? It can do, if it does a repetitive task, like the first robot from Hero was like just this, wooden thing that kind of went around and it followed a series of cams and pulleys and just did repeated behaviors. So it wasn't really autonomous. It was kind of just like a cool device. I think you have to add some level of autonomy for it to be also a robot. So it has to make some decisions with seemingly on its own, right? It has to perform a task in absence of, like human intervention, but also has to be problem solving while it does it, right? So, if you have a robot like an assembly line that just picks in places, you can call it a robot, but it's really doing the same repetitive behavior over and over again. What would be really interesting is like in an Amazon warehouse, for example, where I've got like N number of different things and it can identify that thing and it can pick it up and put it in the right box. And it's starting to do behaviors that are way more complex that you can't just maybe teach it, that require some heuristics or something to accomplish. You're getting closer and closer to, that combined with the physical is what I consider to be sort of a robot. And then there's things like, can it sort of can it be insightful? Like, so a lot of AI, artificial intelligence is there with, cell phone switching networks, a lot of other things in our lives, like, identifying like, images or like what something is. So now you have the thing making inferences and like, okay, I've got this physical thing that's doing non-autonomous, doing autonomous behaviors, but it's also kind of understands its environment and making changes. So I think those things together really what a robot is, but I accept that the definition can be immensely broad.
I think that's a great place to leave off and a great place for us to transition to robots, but also speaking about artificial intelligence and machine learning, which I think is kind of, it's a preoccupation of a lot of our younger students who are thinking about the future of work as well. So I think we've got a few more great questions from students that they can ask themselves, because we're inviting you now to join us on the Zoom link that you can find here. And Todd, again, thank you. I was going to say thank you, but we're going to jump into backstage. So I'll have the chance again. I'd also like to thank the team from Omnis Education, Digital Education, and for all their support in making this happen. That sound good, JC? Mark?
Can you add the link again to the chat, please?
Yeah, it's in the, before I sign off, I'll put it in here. I'll grab it from my email and I'll send it off. And I will, so in 1 minute, we'll be on our backstage bonus. First ever. I'm excited.
Remember the password.
Oh yes, the password. So it should be there on the YouTube stream. So it is Omnis, OMNES. Very good. That was Mark's idea. Very and very cool. So that is the password to get in, and you have the link below on YouTube. And for you guys, I'll send it here in the chat. See you guys in 1 minute. Come join, ask your own questions. Have it's going to be, I think, a great kind of kickback discussion to wrap it all up.
See you then.
See you there.
Thanks, guys.
Thanks, Sean.
All right. You guys, it's in the email.